Hello, this is Nas Babar from NB Networks. Today we're going to talk about binary numbers. I do feel like that, if you really want to understand IP addressing, we need to understand binary numbers. We need to master binary numbers and do them in our head. It will help us quickly learn how IP address is split up and how these numbers play a role. So stay with me. Let's go ahead and get started. On the screen right here, what I have right now is sort of like a reference. Basically what I'm saying is that, as you know, that in case of binary numbers, it's 2 to the base, right? So basically, if you look right here, starting from right to left, I have 1, 2, 4, 8, 16, 32, 64, 128. And 2 to the raised to power 0, 2 to the raised to power 1, 2 to the raised to power of 2, 2 to the raised to power of 3, 4, 5, 6, 7, and so forth. So one thing to remember is that you must have learned in mathematics that anything raised to the power 0 is 1. So 2 raised to the power of 0 is going to be 1, which I have it right here. Similarly, if you have 100 raised to power 0, that's going to be 1, 2. 1000 raised to power 0 is going to be 1, 2. Infinity raised to power 0 is going to be 1, 2. So keep that in mind. That will help you move along in decoding from binary to decimal and vice versa. So let's go ahead and do a live example. How about we do, let's make a column right here, and we say that decimal numbers. Okay, so let's say first decimal number, I want to find out what 0 is. So in case of binary numbers, you have only ones and zeros. You play with only ones and zeros. You will notice that sometime I would say 1 is on, 0 is off. So if you watch me saying that, then you understand that off is 0, on is 1. So let's go ahead and start from here. So 0, I see that all of these right here are going to be off, and that will give you 0. Let's go ahead and do number 1. So if you look here, 2 to the raised to power 0 is 1. Just keep in mind this reference sheet. So you see 1 is right here, 2 to the raised to power 0 is 1. So I know this bit right here is going to be on or 1. Everything else is going to be 0. So let's go ahead and keep going. Let's go ahead and do number 2. So with number 2, I can look it up on my cheat sheet. So when you do this at your home practicing, make sure that you have this reference baseline. It'll help you transfer the numbers from binary to decimal or vice versa quickly. So if you look at number 2, in case of number 2, I know this bit right here needs to be on. I'll turn it off. Everything else has to be off. So 0, 0, 0, 0, 0, 0. This is decimal number 2, and in binary it's going to be 0, 0, 0, 0, 0, 1, 0. So we keep on. Let's go to number 3. So now in number 3, what I see is that this is right here is going to give me 1. Okay. And then this right here is going to give me 2. 2 raised to power 1 is 2. So everything else is 0, as you can see. And this gives me 1, plus 2 equal to 3. 1 I'm getting right here, and 2 I'm getting from right here. Right? So 1 plus 2 gives me 3. It'll clear up. Once you practice, it'll clear up more. Let me jump on to number 5. Okay. So now I look it up, and on the top I say, okay, I'm looking at my baseline, my reference line. 4 plus 1 is going to give me 5. So this has to be on, and this has to be on. Everything else is going to be 0. So this right here, 0, 0, 0, 0, 0, 1, 0, 1 is my binary number, which is equivalent to number 5. Okay, so let's go on to, I don't know, maybe number 14. Okay, I want to find out what's the binary number for 14. So, okay, just look it up and say, oh, 8 plus 4 plus 12 plus 2 is 14. So this is going to be on, this is going to be on, this is going to be on, everything else is going to be 0. Okay, so as you can see, 8 plus 4, 12, 12 plus 2, 14. Or you can do, this right here is 2 to the base 0, this right here is 2 to the base 1, which is 2, 2 to the base 4, 2 to 4, 2 to the base 2, which is going to give me 4. And this right here is 2 to the base 3, 2 to the raised power to 3, that's going to give me 2 to 4 to the 8. So that's number 14. So let's do 19. I would like a binary number for number 19. Well, look it up on your reference line. So 16 plus 2 is 18 plus 1 is 19. Easy peasy. All right, so I put 1 right here, put 0 right here. Let's see, 16 plus 16, 17, 18, 19. So I have 1 over here also. Sorry about that. And then I have 1 underneath 16. Everything else is 0. Again, I'm doing this because when you do the IP addressing and when you do the IP address conversions and when you look at IP address subnets, when you look at the IP address, you're going to look at the network portion, you're going to look at the host portions, and all of these ones, zeros are going to help you if you understand this binary conversion. So this is 19. So as you can see, 16, 17, 18, 19. 2 raised to power 0 gave me 1. 2 raised to power 1 gave me 2. 2 raised to power 4 gave me 16. So if you keep on doing that, let's say, if you keep on doing that, you're going to get this. This would be the, so let me do this. 1, 1, 1, 1, 1, 1, 1. So you have 1, 2, 3, 4, 5, 6, 7, 8 ones. All of them are ones. All of them zeros gave us 0. All of them ones are going to give us 255. You can crank your calculator and check it out and verify. If you add all these numbers right here, 128 plus 64, 192, 192 plus 32, 224, 224 plus 16, 240, 248, 252, 252, sorry, what did I say? 250, 252, 254, and plus 1, 255. So that's how you get that. So these are the numbers with which we play around in figuring out IP address, subnet, in other words.